Imagine, if you will, sitting at a computer, looking at an image, and on it are hundreds of randomly placed points like the red ones you see here in this image. Now I want you to look at every single point and label what they're on top of for this image, but also hundreds, maybe thousands of other images. And I want you to do this for the next few days, weeks, maybe even months. Believe it or not, what I just described is the most common way for how researchers track the changes in coral reef habitats. Sounds fun, doesn't it? So my name is Jordan Pierce, and I'm here to talk to you about my research, which will improve our ability to track those changes across space and time. First, coral reefs aren't just colorful underwater rocks. They're actually a collection of millions of individual organisms called coral polyps, which work together to form colonies that collectively create a habitat that houses millions of other organisms. And they contribute billions of dollars to the global economy through various different ways. And what's really impressive is coral reefs make up less than 1% of the surface of our planet, yet they provide support for a quarter of all marine life. But climate change is hitting our coral reefs with a number of stressors, causing those coral polyps to bleach, which increases their odds of starvation and eventually death. And without fortification, the coral structure that they built starts to become overrun by other organisms and eventually collapses, taking the entire habitat with it. Now, we all want to help coral reefs, but it's important to first be able to track how they're changing from a healthy reef to a degraded one. Unfortunately, as I said, the current most common way for doing so is very slow and cumbersome. What my research proposes to do is to automate this entire process using deep learning, a popular form of artificial intelligence, or AI, and computer vision, which attempts to give computers the ability to see the world in a way that is similar to how we do. I've developed a workflow that will train this computer to recognize objects within existing images of coral reefs in a way that is similar to how you would teach a child, by having it learn from its mistakes. But once fully trained, we can use it to label images that it's never seen before, both quickly and automatically. And what's more is we can use it with other methods like photogrammetry, which is capable of reconstructing a 3D model of an entire underwater scene with millimeter level accuracy from just a few overlapping images. Combined, for the first time, we can give scientists the ability to track changes in community composition and structure both in 2 and 3D. Once again, my name is Jordan Pierce. Thank you for your time.